Hi everyone, this video is for section 3.2, graphing linear models and unit analysis. So this video is going to be on the longer side because it has many parts to it. So I would recommend making sure that you do have your notebook at the ready as we go through. So first off, let's look at the setup. So we're going to look at an example of you starting a weekly meal delivery service. You're planning on going zero waste and will be delivering the food in glass containers. And because using a glass container is going to be more expensive, you're going to ask your customers to pay a one-time service fee of $50. So kind of a buy-in in order to participate in your program. Any meal that they order from you during that week will cost $20. So they can order one meal, they could order 2, 3, and so on, depending on how hungry or how busy they are and how badly they're going to need your service. We're going to let capital T be the total amount you're going to charge the customer. So in other words, how much is their bill going to be? And M is going to represent the number of meals a customer orders in a week. So what I would encourage you to do is when you are working with problems like these, if the variables are provided for you, maybe in the margin, just go ahead and actually write in T is going to be the bill or the cost, and then lowercase m is going to be the number of meals. This just kind of helps create a quick reference guide for you as you continue to work. This problem will have many parts to it, so you may need to reference back quite a few times. So now what we're going to do is we're going to complete the table that you see below to help find an equation that describes the relationship between T, or in other words, that bill or total cost, and M, the number of meals that your customer is going to order. We're going to show the arithmetic to help see if there is a pattern available to us. So first off, we have the number of meals ordered, so remember that's going to refer to the variable M. And I'm just using just some standard numbers starting with 1, 2, 3, all the way to 7. Your customers could order more than 7, but hopefully by looking at the first 7, we can start to see a pattern coming through. And then we're going to look at the total amount of the bill, or in other words, this is our variable for capital T. So remember, with regards to doing any of these programs or ordering any meals, your customers are going to have to pay that $50 one-time fee right away. From there, if they're going to order just one meal, we're going to add $20 to their total. So that means that we are working with, in the case of ordering just one meal during the week, they're going to pay $70. So if we look at 2 meals, again, it's going to be $50, and then we're going to add one meal will be $20, and a second meal will be another $20. So we can kind of clean this up. So just to kind of see if we can start showing a pattern, this would be $50, and this could be plus 2 times 20. This will result in $90 total. So what I did there was I just wanted to note here that since I have 20 plus 20, I can use multiplication to act as a shorthand. So let's do one more together, and then I would encourage you to pause the video and finish completing this table on your own. So again, as always, there's just that one-time fee or that buy-in of $50, then one meal for 20, the second meal for 20, and then the third meal for 20. Again, we could simplify that down. We can have our one-time fee of 50 plus 3 times 20. This will result in a grand total of $110. Now, I would like you to go ahead and pause the video and finish filling out the scenarios for 4 meals through 7 meals. Once you restart the video, those solutions will be available to you to check. Okay, so here are our solutions. Because I was starting to see this pattern, notice that I'm seeing the meal number appearing in my summarized equation here. I'm able to kind of condense this down so that I don't have to repeat that same process for 5 meals, 6 meals, and 7 meals. So now I think I can go ahead and create a general argument here. So instead of writing a specific number for meals, let's just use the variable m. In this case, then, when I'm constructing my answer for my equation, I could say, well, this could be $50 plus however many meals it's going to be. In this case, I don't have a specific number. I'm just going to use the variable m. We're just going to multiply whatever number that is by the $20, and that's going to give us our total bill. So here is our equation. Now keep in mind that you could write this slightly different. So you could write it so that it's so everything is switched on both sides. So we could write this as t is equal to 20 times m and then plus 50. So here's our equation. We're going to go ahead and move forward from here. Now we're going to go ahead and perform a unit analysis on this equation that we found. When you perform a unit analysis, you're basically just making sure that your equation kind of has a certain flow to it. With regards to units, we're referring to the type of measurement that we're using for each piece of this equation. So what I would encourage you to do in your notes is go ahead and write down that formula that you see on your screen, and you're going to start to diagram it out. So to begin with, I'm going to look at T, and I'm going to identify that as my total cost, as we had done before. So you can refer back to your variable reference that you put in the margin of your notes. Well, my total cost is going to be measured in dollars. And then we'll go ahead and we'll put our equal sign in there. And now we're going to go ahead and look at the 20. And the 20 was the cost per meal. So when we think of cost per meal, we actually are creating kind of like a fraction because we're looking at a rate here. So this is going to be cost, which we said is going to be measured in money, and then per meal. Well, it just so happens that M represents meal. So we're going to go ahead and put that multiplication, and we're just going to drop meal down there. Finally, we're going to look at 50. And again, 50 was the one-time fee or cost. And again, a one-time fee or a cost is going to be measured in money. So at this point, you might be looking at this saying, this looks more abstract. I'm not quite sure what I'm looking at. So let me go a little bit further. So what I want to note here is that this meal over here, we can kind of write it like we had done previously with regards to fractions. I want to kind of make it look like a fraction. In other words, I want to clearly see where the numerator or the top part of the fraction is and where the denominator or the bottom part of the fraction is. We're just going to write that over a 1. And hopefully what we're kind of seeing here is, well, I have the word meal on the bottom and the word meal on top. They can cross and reduce themselves out because those units match one another. So now take a look at what you are left with. So we have dollars on the left-hand side. We have our equals. What I have left here is I have a dollar sign over a 1, and then I have plus a dollar sign. So I can continue to clean that up further. So now I'm going to, again, still have my dollar sign on the left, equals a dollar sign over 1, or a dollar sign divided, or anything divided by 1, I should say, is just going to result in that anything, plus a dollar. This tells me that my dimension, or that my unit analysis has worked out. The reason being is because I'm saying some money plus money should result in money. See, the problem would be, so an example of something that would look incorrect would be if I had something like this. So if I said money is equal to meal plus money, this can't happen because these units don't match. Again, if we look at the example over here on the left, because all of the units end up simplifying and matching one another, we are good to go. So this confirms that our equation is good. Now we're going to go ahead and graph this. So what I've done is I've pulled the information that we had previously, and I've summarized it over here on my slide. And again, if we need to, we can always write these as coordinate points. So what I would like you to go ahead and do, so that you don't have to watch me do this on the video, I would encourage you to take the time, recreate the graph that I have over on the left, and fill in these points. So I'm going to go ahead and ask you to pause the video, and when you restart, the solution will be there for you to check. Okay, so here's the answer that we should have gotten. So notice that we're getting a straight line when we graph this. If you recall, so if we look at our equation, notice that it has a very similar structure to the y equals mx plus b. The only thing that's slightly different is that we switched out the variables, so for y and t and x and m over here. But note that those variables are arbitrary. We could have used x and y if we wanted to in this problem, really, and not have run into any sort of issue. So the next thing that I want you to note then, since this is a linear equation, we've also looked at the idea of a y-intercept. And we had said that the y-intercept was always going to be that constant value that we have here. Well, if we come over to our graph, notice where it would start if we were looking at 0 over here. It looks like it's at 0, 50. And again, if we were to do this in our table, plug 0 into this equation, so if someone wanted to join the service but not buy any meals, we're just going to charge them $50. Again, it doesn't necessarily have to make sense in the example that you're working with. Real world sometimes does not always match up with the mathematical world part of it. Okay, it would seem kind of weird to have someone say, I want to join your meal service, but I don't want to order any of your food. I just want to pay you $50 for the glass containers. That's kind of ridiculous. Hopefully you're kind of agreeing with me. I don't know. But let's go ahead and move on to the next slide. Okay, so we're going to touch back on what we had just discussed in the previous slide. The question reads, what is the t-intercept of the linear model? So I had made a mistake in my previous mention of this. Instead of calling this the y-intercept, I do want to remind us all that we are working with a t variable instead in this case. So this would actually be the t-axis in this problem, which means that this point here that I have in pink is the t-intercept. So let's spend a little bit of time on that. So again, with your t-intercept, the question that you want to ask yourself is, where does my graph touch the t? Sorry, I should make that a capital T axis. So in other words, if we are looking at a coordinate point where, again, m was our independent variable and t is our dependent variable, then our t-intercept would have a coordinate point that looks like this. So here we are using a 0. In order to uncover that, that means that we would put 0 in for m. So that means that in order to calculate this, we will have t is equal to 20 times 0 plus 50. This zeroes out, leaving us with t is equal to 0 plus 50, or t is equal to 50. So our t-intercept, again, is going to be 0, 50. So then, again, what does this mean? Well, this means that if someone joins our meal service but does not purchase any meals, they still pay the $50 one-time fee. Again, it may not necessarily make sense, but you never know. Some people are kind of bad with their money, so they might think, ooh, this service is really awesome, but I don't really like any of the food that you're offering this week, so I'll just wait. So I'll just buy in now so I'm a member, and then I'll wait until next week and see what you have on your menu. All right, let's go back to the last slide, and we will call this video done. Now we're actually going to make a prediction using our equation. So we're asked, what if someone purchases 12 meals in a week? And we want to find that total bill. Well, first off, we can kind of go back to our graph and we can say, well, it looks like we definitely are going in an upward trend. So I wouldn't expect my meals, for example, to take some sort of like nosedive along the way. It looks like we are doing a steady increase as we go. So using our equation, I know that we're mentioning 12 meals. So that must mean that we're describing the variable m. So here we have our independent variable. Again, this one is independent because depending on the number of meals that we get, that's going to change or impact how much we're going to charge our client. So we're going to do t is equal to 20 times 12 plus 50. So what I want to note here is just some, presentation. I use parentheses here to indicate that I'm going to do a multiplication between 20 and 12. And again, I want to avoid using, for example, a multiplication sign like so. As you get deeper into algebra, the x used for multiplication can sometimes get confused for a variable for x. They would mean two different things, so I'm going to kind of avoid using that. But now, again, order of operations is telling me I should do the multiplication first. So when I do this multiplication, I'm going to get t is equal to, and let's see, 12 times 20 would give me 240, and then I'm going to add $50 to that. So my final result is going to be, this person's going to spend $290 on 12 meals on your service just within that week. This concludes this part of the lesson. There is one more video that I would like you to check out.